Yes guys, we're back again with another video, and today we've got a logic problem about horses. So let's start. Go find the 3 fastest horses out of 25. We've got a constraint, which is that only 5 horses can race at a time. We haven't got a stopwatch, meaning we only know the order within each race. By order I think they mean like the rankings of who came first, second, third, fourth and fifth. And we have to minimize the number of races. Right, so we've got 25 horses racing and only 5 at a time. So I'm tempted to sort of organize the horses into sections of 5. So let's do it like this. We have A, B, C, D, and E. We have contestant number 1, 2, 3, 4, 5. Just drag this down slightly. We'll label the horses A1, A2, A3, A4, A5, B1, B2, B3, B4, B5. Bear with me. C1, C2, C3, C4, C5, D1, E1, D2, E2, D3, E3, C, D4, E4, D5 and E5. Right, so how should we do this? Well, we know that every race that 2 people will know that 2 horses are slower than the rest, and by that we just know that we can eliminate them from our so we can see this as sort of a knockout stage. So imagine we race just the A horses and we find that A4 and A5 are the slowest. Well, now we don't need to really compare them to any other horses, because if they're slower than A1, A2, A3, well, they're definitely not going to be in the top 3 fastest horses, are they? So we can do that. Let's switch to red. A4, A5. And we can do the same for the B horses. B4, B5, C4, C5, D4, D5, E4, E5. And I want to just add this sort of tally counter, actually race counter. Let's go with the race counter. Use a tallying method. So we've just conducted 5 races: race A, race B, C, D, and E. So 1, 2, 3, 4, 5. Now all that's left is to compare all these 15 horses with each other and find which one's fastest and which ones actually don't care about the slowest. Right. Now let's race the winners of each race. Well, it wouldn't make sense to compare A1, A2, A3 to 2 other horses because we've already compared these 2. So let's try comparing this way now. So once we do that, actually before that, let's say one thing. When I use this notation, I mean A1 is greater than A2, that means A1 is quicker than A2. Or finish the race first, however you want to see it. Right. So now let's race the winners of each race. So A1, B1, C1, D1 and E1 all race. And obviously we eliminate the slowest 2. So we eliminate E1 and D1. Now, since we know that C1, A1, B1, C1 are all faster than these 2, this means that they must also be faster than all of these horses here. Because if, we can write this, if C1 is faster than D1 and D1 is greater than D2, C1 is greater than D2, and since C1 is currently in 3rd place, anything after that, well, we just don't need to pay any attention to. So D2 can go. Again, C1 is greater than E1, which means C1 is greater than E2. And then the same logic for D3 and E3. Alright, we've cut it down quite a bit. And, well, we haven't even done another race yet. but can we cut it any more? Well, we can also say that C2 and C3 cannot be in the competition anymore. Why is that? Well, we said C1 is the slowest out of the 3 we just raced. Actually, I need to add that to the counter before I forget. So we're up to 6. So we can also remove C2 and C3. Now what's left? Wait a minute, can we compare any more? Well, we know that A1 is greater than B1, which is greater than B2. Now, is there a possibility where B3 falls in this top 3? Well, just think. If B3 exists, then B2 and B1 must also be in the top 3 position. But we said that A1 was greater than B1. So we can also eliminate B3. Now what's left? We're left with A1, A2, A3, B1, B2, and C1. Alright, and we just want the top 3. Well, we know out of the lot, let's put purple, A1 is the fastest. So we just left to compare A2, A3, B1, B2, C1. We've just got 5 contestants. Well, if we chuck these last 5 contestants in a race, we're left with simply just, well, 2 of the fastest. Well, we don't actually know what these fastest horses are, which ones they are. But it doesn't matter, because the question asks, let's remind ourselves, find the 3 fastest horses out of 25 and minimize the number of races. Well, we can conclude that it just takes us one more race to what we've got, 7 races to find the quickest. Because if we know A1's the quickest out of the lot, we're left with 5 other horses to compare with, race them, find the top 2 from that race, and there you've got it. You've got your list of 3 fastest horses. And yeah, that's all for me today. Bit of a different problem. Hope to see you in the next. Goodbye.